Let's see here. All right, this is Lab 2, Computing Electric Fields in 1D, and my name is Grayson Hartzell. Now, first, we need to define exactly what an electric field is. An electric field is basically it's basically a field around like a charge. So if you have a positive charge, the electric field is going to be going outwards. If you have a negative charge, it'll be coming inwards towards the charge. And it's force per unit charge at every point in a space. And we symbolize this with the letter E, and the units is newtons per coulombs. Our setup was a charged rod. Um, wasn't necessarily an actual physical setup, but basically the rod had a length L, and we're trying to figure out or approximate its total charge Q. Now, basically, we would compute the electric field at a distance d beyond the rod. To approximate the charged rod, we had point charges. So you can take a line and you imagine in the very middle of the line, you can put a charge, and that charge will represent the total charge of that rod. And that's basically what we did, and that would be N, to represent the number of point charges we used. And method one, we just used one. And method two was multiple, so on and so forth. And as you can imagine, as N is going to increase, your approximations are actually going to improve significantly. Now, to do these calculations, you had to use Excel. Basically, Excel makes it faster, more efficient to um, figure out your approximations for that electric field, that charge of that electric field, using those point charges and various formulas. And you see it from our results here. It's basically plotting. We did some, we did like 1, 2, 3, 4, 5, and then we jumped up to 10, and then we jumped up to 20, and then we jumped up to 50. And those are how many point charges are on that rod. So if you can look here, you can kind of see based on the graph, it converges, it stabilizes some way. And as you can imagine, the larger n gives a better approximation. You can imagine this is kind of like a limit of some kind of function. It's similar. It's like an integral or a limit. And the conclusion is that the electric fields are calculated by using point charges. Excel makes this process more efficient, accurate, and while as n increases, the results converge to the true value of E. Basically, the more point charges you use to represent the rod, the closer that value is to its actual value, its actual charge coming out that rod. And that is all.